All right, in our third part, we're going to be looking at our measures of variation. There are actually only 3 measures of variation. Our first one is called the range, and it will be denoted with a capital R. To find the range, we take the largest value minus the smallest value. It's the distance from the smallest to the largest. The next one is the variance. That is actually defined a little easier, it will be represented by the symbol S squared. Doesn't matter if it's capital S or lower s on variance. Now, if you're talking about sample variance, we're going to use an S squared. Population variance, we'll use our sigma squared, all right? And defining the variance, what it is, it's the spread or variability of the data. How does it fall when I graph it? What does its spread look like? Is it very tight or is it like very sparsely spaced out? That is what variance describes. And it's actually a unit. All right, now the standard deviation is S, and they are related the way you think. The variance and standard deviation are the square or square root of each other. So that's why when you're looking for the sample standard deviation, it's S, whereas sample variance was S squared. The population standard deviation is that single sigma, where the population variance was sigma squared. So let's write this down. Standard deviation will always be equal to the square root of the variance. Or variance will always be equal to the square of the standard deviation. They are related that way, and it's very important for you to know that. Now let's jump right into it. And again, in class, we'll take it a little bit slower because we'll have a little bit more time. These videos are, time limits, so here we go. We're going to find the range, variance, and standard deviation, or measures of variation for the this array. So let's start. Luckily, it's already in order from smallest to largest, so I'll go ahead and total it. And then we're going to call that our variable x. If I take and square that entire row, and again, this would actually be built as a column on a test, but for the sake of keeping our notes to not 20 pages, okay, I went ahead and wrote it this way. Now go ahead and square each one of those, and then we're going to add them together. And once you get them all squared, and again, pause the video if you need to, you'll total them. The total of our squared column would be 513.27. Now, let's start by calculating our measures of variation for an array. The range is the largest value minus the smallest value. 7.7 minus 6.5 is 1.2. Now, another neat little thing to remember that we talked about in class is that the measures of variation are not related the way that the measures of center are. The closer in value the measures of center are, the more they tell us about the data set. Measures of variation are not related that way at all. You can have a very large number and then very small ones. Now, let's go ahead and calculate the variance for an array. On the formula sheet, the variance for an array formula is the sum of the x squared column minus the sum of the column entitled x, that number squared, over n, all of that over n minus 1. We'll plug in the sum of the column entitled x squared is that 513.27. The sum of the column entitled x is 71.5. I'm going to square that number and divide by n. N in an array, just to remind you, is the number of data values. Because there are 10 of them, my n is 10. All of that divided by 9. We're going to put that into the calculator, and I'll write this one out. 513.27 minus 71.5 squared divided by 10 equals, divided by 9 equals. you should get 0.227. All of our variance formulas are plugged in exactly the same way. Kind of neat that way. Now, if we wanted the standard deviation, which I'm not going to calculate here, we will in class, but if you wanted the standard deviation, all you would do would be to take the square root of that number. Now, I don't believe in rounding, so you would still have the entire like 10 place decimal. That's what I want you to take the square root of, and then that will give you the answer, okay? And unfortunately, I did not write that down. Let's go straight into our ungrouped data set. And I'm going to pause the video for just a little bit while I build it. And you can do that at your on your own as well. Okay, once I got it started, I'm ready now to build the new columns. I went ahead and totaled my F, or my frequency column, and found that there were 30 values. To build the columns that we're going to need to calculate the measures of variation, we're going to need an X times F column and an X squared times F column. The X times F column will be just each X times its corresponding frequency. So we'll get 0, 3, 4, 9, 0, 10, 36, and again, feel free to pause the video and build these on your own. 24 and 27. The total of that column is 148. The X squared times F column is the X squared times F. So 0, 3, 8, 27, 0, 50, 216, 245, 192, 243. And that column adds up to 984. I know it went kind of fast, but I don't want to spend the video writing and multiplying and stuff. So stop the video if you need to. Now, let's go ahead and calculate the measures of variation for ungrouped data. For the range can be found by taking the largest value minus the smallest. That gives us 9. There's our range, our first measure of variation. The variance formula for ungrouped data would be the sum of the column entitled X squared times F minus the sum of the column entitled X times F, that number squared, divided by n, all of that divided by n minus 1. We're going to plug in the sum of the column entitled X squared times F is the 984. Minus the sum of the column entitled X times F, that number will be squared, divided by n, which I found by adding up the frequency column is 30, all of that over n minus 1, which is 29. So our S squared, our variance, is going to be 8.754, blah, blah, blah. This is all I want in your answer. If for some reason you were asked to calculate the standard deviation, you would take the square root of the entire decimal that's in your calculator, and that would be 2.959. In class, we'll go over our calculators and how to make that happen. Let's go ahead and finish up example number 3, where we look at group data. Finding the measures of variation for group data. And again, I think I'm going to pause the video and build these columns. We are going to find first the midpoint column and then multiply each frequency times the midpoint. We need that column. And then the F times the midpoint squared column. I'll see you in a minute. All right. Once you've had time to build the columns and find their totals, and I went ahead and summed up the frequency column, the range, well, is not calculable. Let's talk about that real quick. And again, on an exam, I will never ask you for something that's not possible, but I want to explain again why not. The range is not calculable because in order to find the range, I need the largest and the smallest value. I know what the smallest one is because we built these frequency distributions, but I don't know what the largest value is, just that it falls in that last class. So since it's not possible, you will never be asked that, and that's why. Now the variance, we have a formula for the variance of group data. It is the sum of the column entitled X sub m squared times F. That's actually the same as this guy. I don't know why I wrote it differently, but it's the same thing. Minus the sum of the column entitled X sub m times F. That number squared divided by n. All of that over n minus 1. If you're thinking this looks very similar to the last two, yes, it does. We're going to plug in. The sum of the column entitled x of m squared times f is 63,961 minus the sum of the column entitled x of m times f. That's that 1,601, isn't it? That number is squared, divided by n, which is 49. All of that divided by 48. Now, all of our variance formulas are plugged in exactly the same way. I'm going to type it in one more time. This works on all calculators. Some of you that are really good at plugging into your calculator and building the formulas, you can do that on your own. If you need help, here's another try. 63,961 minus 1,601, that number squared, divided by 49 equals, divided by 48 equals. And you should get, for our variance, 242.724. We always want to keep 3 decimal places on our calculations. Now, if I want the standard deviation, I want all of the decimal that was in my calculator, and I take the square root of that, which would give me a standard deviation of 15.580. On exams, I will only ever ask you for variance, because if you miss that one, you're going to miss the standard deviation too. All right, I'll see you in the next video.